Long-term study of soluble reactive phosphorus concentration in Fall Creek, comparison to northeastern tributaries of Cayuga Lake in New York. What did they find? Today we're looking at MDPI, and we're going to look into watershed monitoring and management. So the study focuses on a soluble reactive phosphorus, or SRP, a key driver of eutrophication worldwide and a potential contributor to the emerging global environmental problem of harmful algae blooms, HABs. So not only does this affect your drinking water, but it has severe impacts on the environment. 2 studies of tributary SRP concentrations were taken in the watersheds of Cayuga Lake and the subject of total maximum daily load, TMDL, development process. And due to phosphorus impairment of its southern self, the long-term study compared SRP concentration in Fall Creek in the 1970s with that of the first decade of the 2000s, thus spanning a period of change in phosphorus sources as well as regional climate. And the spatial study used data collected between 2009 and 18 and compared the SRP concentrations in Fall Creek to levels in northeast tributaries that flow into the lake close to areas where HABs have been problematic. And the SRP was measured using standard procedures. Flow-weighted SRP means concentration between 15 and 30 in all years studied in the 1970s and 2000s, with the exception of 2010. And the annual discharge in Fall Creek showed no trend between 1970 and 2018, but a higher proportion of high stream flow was captured in 2000s compared to 1970s. So this is definitely a problem with eutrophication, and as we can see, the Cayuga Lake watershed is part of the Seneca, Oneida, Oswego river drainage in New York State, as we've done a lot of videos on this watershed, the northeast region of the United States, and the center of Cayuga Lake is located at latitude of 42.692, north longitude of 76.6898 elevations in the Cayuga watershed between approximately 120 and 600 milliliters above sea level. So we can see the watershed right here. Now the long-term study compares the SRP concentrations in the 1970s with those of the first decade in the 2000s and looks at various characteristics on the 2 time periods. And as we can see, there's 2 different time periods of spatial study, long-term study. What do they find though? In short, they found that particulates removed filtration were through a 0.5 cellulose accelerate filter with an SRP analysis. And they also found that the hydrology of Fall Creek exhibits considerably internal variability in discharge between 1972 and 2018. As we can see this example right here, they have flow-weighted SRP with error bars, and 1 standard error means the 1970s and 2000s. The box and whisker plots of the flow rates at the time for sampling were collected in 1970s and in the 2000s as well. We can see the information here. And the annual discharge in Fall Creek is highly variable from year to year and shows no trends between 1972 and 2018. There's no statistically significant change in SRP concentration relationship between the 2 periods, and given a volume water falling the creek of in the 2000s delivered the same amount of SRP to Cayuga Lake that it did decades before. Higher flows captured the sampling in the 2000s have resulted in proportionally increased SRP concentrations. So there is more SRP, there's more eutrophication. Definitely this is something to take a look at for soluble reactive phosphorus. But how do you know if you have soluble reactive phosphorus in your water and what impacts is it having on your environment? You have to have it tested. And that's why it's always a good idea to periodically test your water for phosphorus.